I was asked in an interview to design group chat in WhatsApp or any other messaging application like Slack. So if you are thinking about an approach where when the user sends a message, it goes from client to the gateway, and then the microservice will insert that message into the database for the persistent storage, then I can tell you this approach will give you a rejection in the interview because I gave the same answer. Of course, there were other microservices like authentication microservice, there is connection manager, there is fan out microservice, there is notification manager, and much more. But if your approach is the microservice will insert the message in the database directly, this is not correct. Why? Watch this video till the end and you will get all the answers. This video can help you crack your dream company offer letter. And the other thing is, the content is completely free. And I'm putting a lot of effort and energy to create all such content with which you can crack your dream company offers. So what I want from you is to make sure you subscribe to the channel and share it with your family and friends so that all of us can learn and grow together. Hi, my name is Mohit Chavda, ex-Salesforce, ex-Walmart, and in today's video, we are going to discuss about designing a group chat in any messaging application like WhatsApp, Facebook Messenger, or Slack. So in this video, we will focus on the flow where the user can send a message to a group and how that message will reach out to all the members who are present in that group. So let's start with some of the very basic high-level components which will be required in our design. So the first component is the client. If you want to know in detail what are these basic components like client, server, gateway, you can refer to this video in which we have talked in very much detail about all of these concepts. But in summary, if I have to tell you, client is the user who is using the application on the mobile or the website on the browser. So the end user using application on mobile or on the browser on desktop is acting as the client. Then there is gateway because client never interacts with the server directly. It always interacts via gateway, and then there is load balancer as well. So here when I am drawing this component, you can take it as like we have the gateway here and after that there is load balancer. So I've not created a separate component for load balancer, but if we are creating here the gateway, it is giving that indication. So when we talk about the API gateway, it has three major responsibilities. First is that it will check for the JWT token for the authentication or authorization of the end user. Number two, the API gateway also checks for the rate limiting, which helps us preventing all the DDoS kind of attacks. And number three, the API gateway will basically forward the request to the correct microservice. There can be many microservices in our design, so it will forward the request to the correct microservice. So all that functionality will be handled by the API gateway. And then we have the load balancer, which basically helps us to send the request to the particular server. Because when we talk about the system design, we always talk about the distributed systems. There are always multiple servers, multiple database, multiple replicas to avoid single point of failure. So even when the API gateway forwards the request to a particular microservice, in that microservice also there will be multiple servers. Now your request will go to one server, right? So to which server the request should go to, that will be identified by load balancer. It uses technique like consistent hashing to identify to which server this particular request should go to. Now after API gateway and the load balancer comes our other component, which we have named as message ingest service. So is it a microservice? Yes, this is a microservice. So imagine user A has sent a message, okay? So it will reach out to this message ingest service. Now when we are talking about the communication between the client and the server, which protocol will be used here? Are we using the basic HTTPS REST API protocol here? The answer is no. But why? Generally we use HTTPS REST API in most of the APIs. But when we talk about messaging application, we use WebSocket protocol. But why WebSocket? The reason is, if we talk about HTTPS REST API protocol, in this the client has to send request to the server, and on that request server will give the response back to the client. One thing to remember in HTTPS REST API protocol is that server cannot give the response back to the client if there is no request from the client. So client has to send the request to the server first, to which server will give back the response. Now just imagine there are two users A and B, and here is this server, okay? So here I am writing A and here I am writing B, and this is the server. Now say for example B wants to know if there is some message from A to B or not. If we are following this HTTPS REST API protocol, then B will continuously keep on pinging to the server to keep on checking if there is any new message for B from A, because server cannot give the response to B without any request. So B will continuously keep on checking from the server. So what all approach can we use? First is polling, which means that B will keep on polling to the server after some frequency. It can be say after every 10 seconds, B will send a request to the server and server will give back response to the B. But this is very inefficient because there can be so many users and each of the user will keep on pinging to the server. This means there will be a huge load on the server because all of the users will keep on pinging the server for every other user. This doesn't look as a good approach. Another way of doing is to have the long polling, where the client can create a session with the server and that connection will stay for some time. After that, once the connection ends, the client will again open a connection with the server for some time. But when we talk about the message application, we want a real life kind of experience. So whenever someone sends a message, we instantly should get the message from that person. So that's why this HTTPS REST API protocol is not really fruitful, because even if you are getting the message after 10 seconds of delay, the end user is not getting the real time of experience, which is a mandatory thing for the message application. Chats and messages are interesting because these are real time. You get the message instantly. But if there is delay of like 10 seconds every time, it doesn't make any sense. It will degrade all of the experience. And that's why when we talk about the message application, we use the protocol of WebSocket. WebSocket is a bi-directional protocol. So when we talked about the HTTPS REST API protocol, one condition was that the client has to send a request on which the server will send back the response. So the server cannot send a response to the client without any request. But when we talk about the WebSocket protocol, it is bi-directional, which means the server can send the data to the client without any request from the client. So when we talk about this case in terms of WebSocket, if the server gets a message from A for B, then the server can directly send the message to B. B does not need to make a request to the server for getting the data. Server can directly give back the data to B using the WebSocket protocol, because this is bi-directional, which means there is a connection built between the client and the server can give the data to the client in real time. So that's why when we talk about the message application, we use the WebSocket protocol. Now the WebSocket is also built over the TCP protocol. Okay, so if you want to know about TCP protocol in detail, you can refer to this video of mine where we have discussed everything in quite detail. But in summary, we are using the WebSocket protocol, which is built over TCP, and that is required for the message application because it gives you correct ordering of the messages. For example, when we see a chat application or message application, we see ordering of the messages, and that is an important part. And another important part is TCP protocol ensures that no data is lost in between, and which is required part of the message application. Okay, so we are ensuring the ordering is maintained, there is no loss of data, and we are also giving the real-time experience using the WebSocket protocol. Alright, so this was about the protocol, that we are not going to use the REST API protocol and we are going to give preference to the WebSocket protocol in this message application flow, right? So now we have the message in the message ingest service. So the first thing that may come into your mind is that we need to persist this message, right? So the first thought is always that we insert this message in the database, right? This is the first thing that comes to our mind. So from the message ingest service, what we'll do is like insert the message in the database. But here comes the major part. This is not right. You cannot just put the message directly to the database. But why? What's the problem? The problem is that you may imagine there are huge amount of writes operation which happens. So when we talk about the chat application, both of the users are sending the messages. You can imagine the read versus write operation. The ratio is not much different because you generally read the message only once. Yes, you can always go back and check the history, but that is very rare. Most of the times the chat is happening at that moment. So you read the message, you write the message. So number of write operations are huge when we talk about the chat application. And one thing to remember is that whenever in system design, if you are having huge amount of write operations, then you cannot just insert everything directly in the database because that is not scalable. Now, if for each and every message from the ingest microservice, if you are doing the insert operation in the database, it means that there will be huge load on the database. We are making so many write operations in the database, and that won't scale. It won't work on huge scale and your complete system will go down. One more issue with this approach is that if the core responsibility of the message ingest service is to insert the message in the database, then it has to wait for it. Right? Till the time the message is not inserted in the database, the microservice will have to wait, right? Because it's a core responsibility of this microservice to insert the message in the database. And there can be many cases like when you try to insert the message in the database, it may fail. So first the message ingest service has to wait for it, and in case that fails, it has to also retry for that part. So it puts a lot of responsibility on the message ingest service, and it will also slow down the complete process because this is kind of the major or the first microservice where there will be a huge load, and we have tightly coupled it with the database operation. So overall this design flow is not at all scalable. Okay, so the first approach that comes to your mind, from the microservice you will insert it in the database to make it persistent. If you say this answer, high probability you'll get the rejection in the interview. So that's why to insert the message in the database is not the core responsibility of the message ingest service. Now does that mean that we won't insert the message in the database? No. We would for sure insert the messages in the database, but that won't be done by the message ingest service. So I have removed this arrow from here. Okay, that would be done separately. So we have removed all the arrows here between the ingest service and the database because it's not the core responsibility of the ingest service to insert the message into the database. So then what's the major role of this message ingest service? Message ingest service will do many things, but the most important part of this microservice is to publish the message into the message queue, and here we will use the Kafka message queue. Okay, so I am writing it here, the Kafka message queue, and the core responsibility of this microservice is to publish that message in the Kafka message queue. Now this is a very important design pattern that you should remember. Okay, whenever there is a case where there are huge amount of write operations happening, it can be any scenario. For example, we are talking about the message application scenarios where there are huge amount of write operations. It can also happen in some other system design problem. If you see there are huge amount of write operations happening, you should never directly insert that in the database. Instead of doing that, you have to use a message queue like Kafka. Okay, so instead of putting the message in the database, you insert that message in the message queue. So basically Kafka is a distributed system. Okay, and it is used where you have high amount of write operations. Say for example, you have to put all of the things in the Kafka message queue. It is built for that part. It is really good for that part. Now it can store the data for some time. It's not same as the database, because in database we tend to keep the data, persist the data for huge long period of time, but generally in Kafka you keep the data for short durations, like it can be 7 days, or you can also configure that time zone, but you can generally imagine we keep the data in it for like 7 to, you can say, 30 days. So few weeks or month, you can say, we can keep the data in it. So this has the storage capability, but this is not like the database persistent kind of storage that the data will stay here for many years or so. But this is really good when there is huge amount of write operations. We will discuss more about Kafka message queue later in this video, But for now, just understand, instead of putting the message directly to the database, what we are doing is we are putting it into the message queue. One reason is, as I said you, if you will put all the messages directly to the database, it is not at all scalable, whereas the Kafka message queue is built for that kind of capability. Another good thing of Kafka message queue is you can use the pub/sub model here. Like a lot of other microservices will keep on listening to the events from the message queue. So in this way, you can interact with various multiple microservices using the message queue. I'll show you whatever data we are pushing in the message queue from this ingest microservice. It will be used by many other microservices, and our complete system will build or revolve around that part. You will see that more later in this video, but for now we need to understand the major or the core responsibility of the message ingest service is to send or publish the data to the Kafka message queue. Now I will also show you what kind of the event does the message ingest service publish to the Kafka message queue, but before that, let's also see what else the message ingest service is doing apart from pushing the data in the Kafka message queue. So one thing that it will also do is do the basic validation of the messages. Say for example, from the client we send the message to a particular group ID, right? So it will do the basic kind of validations. First, say for example, the message is not empty. Then it can also validate whether the group ID, which means the group to which the client sent the message, whether this user is part of that group or not. Now how the message ingest service will check that, whether the user is part of that particular group ID or whether that group ID is valid or not. It can basically check that from the cache, okay? Or it can make a lightweight call through which it will identify whether the user who has sent the message is part of the group ID or not, and the group ID is valid or not. Then this message ingest service can also do some kind of basic validations on the message, like the abuse or the spam filter check. Like basically it can check for the basic filters or the keywords from the cache, and it can basically simply validate if those kind of blacklisted words or some keywords are part of the message or not. Now apart from this basic kind of validations, we know that the main core responsibility of the message ingest service was to push the event in the Kafka message queue. Now it won't just simply give the message to the Kafka message queue, it will do some kind of enrichment on top of that, and finally it will push that particular event in the Kafka message queue. Let me show you one example for the same. Say for example, the user A sent a message in the group like, hey team, let's meet at 5 p.m. You generally see all that kind of formal conversations on the Slack group chats, right? So say one of the users sent this message. So what the message ingest service will do, it will basically enrich the data. So here you can see it has created the message ID. Message ID will be kind of the UUID which is created by this server. Then you can also see fields like the channel ID, the sequence number, the sender ID. Of course, there is the message which is part of the content. Then there is a field named as created at, and you can clearly see it has named the field as message created. So this is the event which is published to the Kafka message queue. So you can clearly see this event identifies or clearly tells that the new message has been created, which means that user has sent a new message. So that's why the event name is message created. Now this kind of event is pushed to the Kafka message queue, and this is done by the message ingest service. Now once the message ingest service publishes this kind of event to the Kafka message queue, it will also acknowledge the client. Of course that would happen via the gateway. The server doesn't directly interact with the client. That is the basics which we covered in this video, but this is also one of the responsibility of the message ingest service, that it will acknowledge the client. Based on the message ID, it will give the status back to the client. So the client will get to know that the message has reached the server. So based on that, the client can show the single tick on the UI, right? Which means that the message has reached the server. So you can clearly see the message ingest service has done the basic validations, like it checked whether the group ID is valid or not, whether the user who has sent the message is part of that particular group ID or not. It also checked for the basic validations on the message, like the abuse or the spam checks, and after that the core responsibility was to publish the event like this, where it has done the enrichment. You can see it has added a few of the fields here to give more information to the message queue, and the event name, it is message created, so it has pushed that in the Kafka message queue, and then it has also acknowledged to the client, through which the client will get the information that the message has reached the server. So these are the roles of the message ingest service. Another thing to note down is that the message ingest service does not perform the write operations to the database. This is not the responsibility of this microservice. It will also the role of sending the messages to all the people who are part of the group. This is also not part of the message ingest service. So this way, this message ingest service is decoupled. It has its own set of responsibilities and it can be scaled according to that. Now here we talked about the case where client will send the message to the group, okay, and we also said that we will use the WebSocket. So this is kind of, you can say, the request and response through the WebSocket. So you can see in the request, the client has sent the group ID, which means it mentions to the group where the user wants to send the message. And then of course there is body, which contains the message, and there is also type of the message. It can be normal text message, and we can also share some image or video with it. So this is done via the WebSocket protocol. And in the response corresponding to the ID, we have also given the status, through which the client is ensured that the message has reached the server. Now you may have a question in mind, like, because we said that the message ingest service will check whether the group is valid or not, the user is part of the group or not, how will it check? So as I told earlier, it can check in the cache, or it can also interact with another microservice, which can be the group service, which is also a microservice, which will contain the information related to group, like which group is there and who all are part of that group. So it can check with the cache or the group service to identify that kind of part. So here you can see that the message ingest service, while pushing the event, it created the message ID, right? So just in case, while it tries to push this event to this Kafka message queue, and in case it fails, so what the message ingest service will do is it will retry to push the event in the Kafka message queue again, and it will keep the same message ID, which means that the message ID is idempotent, which further means if you are retrying to send this event to the Kafka message queue, it won't duplicate anything because the message ID is consistent. It is same when you are retrying, right? So in case one of the events which gets published to the Kafka message queue is successful, it will clearly see if any other duplicate message is coming with the same message ID. Also, as we said, the message ingest service will do the basic validation of the message. So just in case some message is like corrupted or very long, which crosses the limit, that can be made part of a separate queue, which is DLQ. The full form of DLQ is dead letter queue. So all the messages which are corrupt, oversized, or which do not fulfill the requirement of basic validation can be put in this DLQ, that is the dead letter queue. Similarly, for the message validation, we want it to be quite quick, lightweight. So what we will do is like do the basic regex checks there. We will simply check for the message limit, and we also have some of the blacklisted keywords and the regex, which would be part of the cache, and it would simply check if any of those blacklisted words or regex match is present in the message which is sent by the user. So all these basic checks and validations are done at the message ingest service level. If we talk about the deep checks related to spam or abuse, that is generally done at a different microservice, which is handled at the machine learning level. So at machine learning, we generally do the deep checks for the abuse or the spam. So for all that kind of work, it can be redirected to this separate microservice, but the message ingest service, it needs to do the basic lightweight validations on the message only. Similarly, if a user is marked as the blocked user, that can also be checked at the basic cache layer by the message ingest service. So it will do the basic lightweight validation checks, and then it will do this kind of enrichment, and the core responsibility is to publish the event to the Kafka message queue. So all these basic checks can be seen in this kind of flow. So basically it will check the Redis cache, It will check whether the user ID through which the message is sent, whether it is blocked or not. If the user ID is part of the blocked list, we can simply reject it. After that, it can simply check again in the Redis cache whether the user is part of the group ID or not. Just in case the user is not part of the group ID, then the user is not allowed to send message to the group and we can simply reject it. Then further, the message ingest service can check for the basic checks like the length of the message. It can check for the regex and compare it also with some of the blacklisted words. In case all those checks pass, it will enrich the event and publish it to the Kafka. Now apart from this, here you can also see in the event we have this message ID. This message ID, as I said earlier, can be created as a UUID or as a Twitter snowflake approach. If you want to know more about that, you can refer to this video. In the tiny URL system design, we discuss about the various approaches through which we can create a unique kind of number. We discuss about the UUID approach. We also discuss about the Twitter snowflake ID approach. So you can refer to this video. Now, before I talk more about this Kafka message queue component, let me also show you what all other high level components will be required for this group message application. So let's go down and see all the components which I have mentioned here. You can see here we have the client, gateway, message ingest service and the Kafka message queue. We have discussed some points about all of these components already. Now apart from all these components, you can see there are few more components like delivery service, storage service, notification service, search indexer. We will discuss about each of these in detail later in this video, but I'll give you one-liner summary for each of these right now. So the delivery service will act as the fan out, which means it will perform the task of delivering the message to all the people who are part of that group. Storage service will basically write the batch of messages into the database and perform few more tasks. Notification service will help to send the push notifications or in-app notifications to the users. Like you might have seen the WhatsApp notification on your mobile phone, that will be done by the notification service. And the search indexer will basically help us for fast message search. Now apart from all these components, we will have one more component which I'll mention here, which is the connection manager, or you can also say it as registry. This will help us basically to identify which user is connected to which machine. So basically each of the user will be connected to a machine, and each of the machine generally has like more than 48,000 WebSocket connections. So it will basically help us identify to which port the user is connected to. Okay, so let me add one more service here, which will be the presence service. The role of presence service is to tell you last seen of the user and also whether the message is delivered to the user has seen the message or not. So all that kind of information will be provided by the presence service. So these are the major components that will be required when we talk about the message flow in a group conversation. We have not mentioned components like the authentication service or the profile service and much more, because generally in interview you get like 45 minutes and you cannot discuss all of the components in 45 minutes. So because in this question our focus is on like sending message in a group chat, so these will be the components that we will focus on. Now I mentioned here all the components because most of these will interact with the Kafka message queue events here, and through that all the communication in the system will take place. So now let's discuss about Kafka message queue. So when we talk about the chat application, there are millions of messages per second and your system has to perform a lot of tasks. Like each of the message needs to be stored, delivered, indexed and notified. Now you can't block the sender on all of that. So here the role of Kafka message queue comes. It provides durability because the messages can stay in the Kafka for like 7 to 30 days as per our configuration. So it makes sure that the messages aren't lost. So that's why our first step was not to save the message directly in the database. We pushed the event which contains the message in the Kafka message queue because it provides you durability. But the major benefit of Kafka is that it is providing you decoupling. So here you could clearly see the role of message ingest service was to just push the event in the Kafka message queue. if the message ingest service had to write the message to the database, it would have resulted a lot of responsibility on this microservice, because then it has to wait for the message to be written in the database, and in case there is some failure, it has to wait on that part. Now we have removed that role from the message ingest service. It has to simply push the event to Kafka message queue, and it's not the responsibility of the message ingest service to see who is consuming that message. So it is just acting as a producer. It is giving the event to the Kafka message queue, and after that its role is done. So here the use of Kafka message queue helps in decoupling, because now you will see a lot of consumers like the delivery service, the present service, and much more. They will consume the events from the Kafka message queue, and the message ingest service doesn't care about it. Its role is done once it simply pushes the event to the Kafka message queue. So in that way, all of the microservices can scale independently because they are decoupled. So as I talked about scale, so the next important feature of Kafka message queue is scalability. Now because each of the microservice will be consuming from the Kafka message queue, so all of these are independent of each other. They can be scaled independently, so there is no tight coupling, and through the Kafka message queue events, all the communication will take place. Another thing which Kafka makes sure is the ordering. So the ordering of conversation is also handled by Kafka partition. So you can clearly see use of Kafka is really important in this system design. So let me remove all of these points here. Now there are multiple events or topics which we will talk about related to Kafka, but we saw one of the events, this one, message created, which was done by the message ingest service. So let's discuss about it first. So here is the example of the message created. You can see the event is message created, and it has few more fields like the message ID, channel ID, sender ID. The content contains the message, and it also contains the created time. Now the point comes, this event which is message created, which is now part of this Kafka message queue, which all components will consume this. So here is the list of consumers for this message created event. So first of all, your persistent service or the storage service will listen to this event, and the role of storage service will be to write the messages in the database. Now it won't do that for each and every message one by one. It would do that in a batch, but we will discuss about it later when we discuss about the storage service. But the storage service is a consumer of this message created event. Now apart from the storage service, the fan out service or the delivery service will also be a consumer to the message created event. Now the role of delivery service or the fan out service will be, it will send that message to all the people who are part of that group. So one user sent a message in the group, the delivery service will send that message to all other people who are part of that group. Apart from these, the search indexer will also consume this message created event from the Kafka message queue. Now what it will do is, it will index this in the Elasticsearch so that you can search this message easily and quickly. Now further, there are more few optional components that can consume this message created event. One can be your abuse detector. You know, we discussed about this machine learning kind of component which can check for the abusive or the spam messages, right? Because the message ingest service will just do the basic kind of validation of the messages, but if we want to check the complete message properly related to abuse checks or the spam checks, then that can be done by a machine learning related component. So how will that happen? That will also happen through the events which are present in the Kafka message queue. So we can create an optional component here which might not be required, which you can ignore in the interview because our focus is more on the message flow. But yes, we can optionally create like the abuse detector and also the analytics service, and both of those can also listen to this message created event, right? So you can clearly see all of these components like the delivery service, the storage service, the search indexer service, analytics, abuse detector, all of these are picking the events from the message queue. So you can clearly see all the communication in this design which we have built is happening through this Kafka message queue. So you can think of it as like pub sub model or the consumer producer model, but basically this component message queue is really important. So from one of the component, you will add the event, and there are a lot of listeners which are listening to this particular event. Now we discussed about this message created event, but there can be other events as well. Like there can be the message updated event or topic, which happens when you edit a message. There can be message deleted topic or event, which happens when you delete a message, and there can be also a typing indicated topic or event, which happens basically whenever someone is typing a message. So all such kind of events or topics can be part of the Kafka message queue. Those can be pushed by one of the components, and many other components will keep on listening to that particular topic or event. So clearly you can see the importance of Kafka message queue in this design. It is acting as the central event bus for all the message lifecycle events. So one more use case of Kafka message queue is the ordering of the message. You know, when we talk about the chat application, the ordering of messages is really important, right? So what Kafka ensures is that there is ordering of message in a partition. So in a message queue, there can be multiple partitions, and what it ensures is that in a particular partition, the ordering of the messages will be maintained. Now, if you want to know in detail about partition and how Kafka works, you can put that in comment section and I can create a separate video on that part. But for now, you need to understand there can be multiple partitions in the message queue. What Kafka ensures is that the ordering of messages in a particular partition is maintained, but it does not maintain the ordering between multiple partitions. So it ensures ordering within a partition but not across multiple partitions. So what we can do is, like, we can do the partitioning based on the group ID. So say for example there is a group ID 1, 2, 3. So all the messages of that group will go to a particular partition, and by default it makes sure that the ordering of all the messages in that group ID is maintained. Another main point is the decoupling that this message queue provides. As you can see, there are multiple consumers to the events which are present in the message queue. All of these are independent of each other. They don't need to wait for any other component. They can independently listen to the events and do their work. Now, as the Kafka message queue provides you durability, we discussed that you can keep the message in it, say 7 to 30 days. You can configure that. And as we discussed earlier, there is this message ID which will use the concept of idempotency. So it makes sure that there is no duplication. So there is durability and there is delivery guaranteed using the Kafka message queue. So if we talk about the simple flow, it can be something like this. The client sends the message, it reaches to the message ingest service. The message ingest service will do the enrichment, like it will add the message ID and many other fields. It then publishes that event to Kafka. So the event or the topic name will be message created. And as we discussed, in a partition, Kafka ensures that ordering is maintained. So we will do the partitioning based on the group ID. And once it publishes the event or topic to the Kafka, it acknowledges back to the client, which means that the client knows that the message has reached the server. Now Kafka is a distributed system. Once the message has reached Kafka, there are multiple consumers of that event. For example, here you can see all of these are the consumers of this topic. First is the storage service. It will read the message event and its work is majorly to store that message in the database. Because although Kafka provides you durability, the message stays there for like 7 to 30 days. But you want your message to stay there for many years. We want database for that part. So the role of the storage service will be to store that message in the database. Next, we have the delivery service, which will read that event and push that message to all the group members. Then we also have the search service or the indexer that we talked about. It will basically index that in the Elasticsearch so that you can search the message quickly. And then we optionally can have many other components listening to it, like the abuse detection, which will use the machine learning to check for any abuses or the spams in the message. And apart from this, the analytics service can also consume that event and use it accordingly. Now talking about the Kafka, as I told you earlier, it can keep the data for like 7 to 30 days. Now this can be configured, but you can clearly see this time period is enough that you can use that in rebuilding the database if required, or inserting all that data in the database for the complete persistence. Talking about the partitions, it can have hundreds to thousands partitions, and we will do the partitioning by the group ID because Kafka ensures ordering of messages in a particular partition. Now, as I said earlier, Kafka is a distributed system, so it avoids single point of failure. So the replication factor can be 3 for durability. So you can clearly see it's not like only one thing, and if it goes down, everything goes. So there is replication. So we have kept the replication factor as 3 here. And lastly, talking about the throughput, Kafka can handle millions of messages per second if partitioned well. So that's why in the beginning I said whenever you are building a system where there are too many write requests, don't make anything that from the server you are directly putting that in the database. This system won't scale. So whenever you have a lot of write operations, make sure that you use the Kafka message queue because it can handle that kind of load. It is built for that way only. So clearly you can see all of these consumers are picking the events from the Kafka. So even if some of the service or the component fails, there is no worry because the data remains in Kafka for like 7 to 30 days, and whichever component failed, they can retry. So by this we have the fault tolerance. So even if there is some fault in one component, even if one component fails to do something, there is no worry because the data is staying there in Kafka for like weeks and you can perform that action again. So we saw here that we pushed the event to the Kafka and the event contains the message. But when I was understanding this flow for the first time, I had questions in mind. So the first question that in my mind came was, when is a message removed from Kafka? So here is the answer. So Kafka does not remove the messages after they are consumed. Say for example, when we talked about this case, like you have the message created event which contained a message. Now even if all of these consumers consume this message is not deleted. It stays there. Okay. So here is the part. It does not remove the message after they are consumed. As I told you earlier, each topic in the Kafka has a retention time. So for example, if we keep it as like 7 days. Okay. Similarly, there is a retention size. For example, 100 GB per partition. So after this limit has crossed, like 7 days have crossed, the old messages are deleted automatically regardless of the consumption. So say there was this message created event which had a message. Now say for example on the day 1 only all of the consumers consumed this message. Even after that, this message will stay in Kafka. It will not remove the message once all of the consumers have consumed it. It will be removed automatically once this retention time is over. So after 7 days, automatically this message will be removed. And it does not matter if any of the consumers have not consumed it yet. Okay. So say one of the consumer missed this message, it doesn't matter. It will be still deleted because the retention time has crossed, right? So irrespective of the consumption of the event or the topic, it will be removed after the retention period has crossed. So the use case of this part is, say for example, if any consumer fails or restarts, right, which can definitely happen. So it can replay the messages by reading from the last committed offset. Now what does this mean? I'll explain you later because this was one of the questions in my mind. Now the second question in my mind was, as we know there are multiple subscribers to this Kafka message queue, like there is notification service, there is storage service, there is presence service, and there is delivery service, right? So all of these are consumer groups. Now that we see that there are multiple consumer groups to this Kafka, how does Kafka know who has consumed what? As there are multiple consumers, so how does Kafka know which consumer has consumed what? The answer to this question is something called as offset. Now offset is a metadata which is assigned by Kafka itself, via which it differentiates between different consumers. So each of the consumer group will have a offset. Now you will say we saw this example, right? Message created event which was published by the message ingest microservice, right? Now this event does not contain any offset. So with this we get the answer that the producer, like the message ingest service or any other service which is publishing this event, they never set the offset. Offset is generated by Kafka itself. For example, for this event, Kafka stores it in the partition number 5. So it generates an offset for it, which is auto generated by Kafka, right? For example, you can see here 3001 is the offset, and in the data payload, this message payload would be present. Now to understand in easy terms, each of the consumer group maintains an offset per partition. So each consumer group will have an offset per partition, and offset is a pointer to next message to consume. So offset is acting as a pointer which tells the consumer group which is the next message that it needs to consume from the Kafka. This is required because there are multiple consumer groups. We saw here there is delivery service, there is notification service, there is storage service, there is present service. Each of these are consuming the same event, which is like message created. So now each of these are independent of each other. They can work on that event independently. So for that we need an offset for each of these consumer groups, right? That's why we have mentioned here each consumer group will maintain an offset per partition, and offset is the pointer to next message to consume. So this is an example. We have mentioned the partition, offset and the consumer group. You can clearly see for group A, you can assume it like the delivery service. It has offset, say for example 100, and the partition is P0. Similarly, there is group B. You can assume it as like notification service. It has a different offset because both of these are independent of each other. They can perform their work independently. So that's why they're offset, which means the message till point they have covered things will be different, right? So you need to remember each consumer group per partition will have a different offset. Now this is really helpful as using this approach, each group can consume independently. So multiple consumers can read the same data without affecting others. Now this is really helpful. Let me show you how. So for example, this was the Kafka message queue, right? And there are multiple consumer groups, you can say. One is the delivery service, one is the notification service, and one is the storage service. Okay. So all of these are basically reading the same event. But now it's not the responsibility of Kafka to identify if all of these consumer groups have consumed the event or if any of these have failed the event, because these are independent. So there are independent offsets for each of these. Now once a consumer group consumes the message completely, it's a responsibility of the consumer group to update the offset corresponding to its consumer group. It's not the responsibility of Kafka to track the things. We mentioned in the beginning, even if none of these consumer groups have consumed the event, if the retention period is over, that event will be removed from Kafka. So it's not the responsibility of Kafka to track the things. That's why there are different offsets, and it's the responsibility of the respective consumer group to update the offset. So this is great because say for example notification service, it fails to use that event, it doesn't impact other consumers because they have their separate offset. Now we mentioned here that each consumer group maintains an offset per partition. So the next question which came to my mind was, where does Kafka maintain offset per topic per consumer? Like, is it a database or what is this kind of storage? Where is it getting stored? Because we have multiple offsets now as there are multiple consumer groups. So where are we keeping that data related to offset? The answer to this question is Kafka stores offsets in an internal compacted topic called consumer offsets. So just like we saw other topics like message created, message updated, message deleted, and much more, Kafka stores offset in an internal topic which is named as consumer offsets. So basically this topic consumer offset, it exists in every Kafka cluster and it is automatically created and managed by Kafka. So the important part is offsets are not stored in memory or any external DB. They are stored in the Kafka topic named as consumer offsets. So just like any other topic data, offsets are stored in the Kafka itself. Now as we have talked about the consumer offsets topic, let's also see the structure of consumer offsets. So it's basically a key value compacted topic. The key would be the consumer group ID plus topic plus partition, whereas the value is the last committed offset and the metadata. So let's see an example. Okay. So say the consumer group is storage service, okay, and the topic is message created and the partition is 0. We mentioned that each group per partition will have a separate offset. So that's why the key is the combination of your consumer group, which can be the notification service or the delivery service or anything else, right? Similarly, topic can be different for each, like message created is one, message updated, message deleted, and much more. And then we mentioned the partition because offset will be per partition. So here the partition is 0 and you can see there is a committed offset number which is 1500, which is specific to this part, this particular consumer group and the partition and the topic. And if we talk about the same storage service, the same topic, but the partition is different, you can see the committed offset is also different. And if the consumer group is different, you can see we are taking the same topic, partition same as the first one, it has a different offset. So basically you can take it as like key value pair, just like we normally use the hash map or the dictionary. So it's a key value pair, but using this it can clearly and easily differentiate, and it makes all the consumer groups independent of each other. They can utilize it independently. Now we have mentioned here compacted topic. What does this mean? So this topic consumer offsets is bit different from other topics. Like for example, we talked about message created, message updated, message deleted, and there can be many other topics, right? But this topic, consumer offsets, is bit different from these. For these topics like message created, message deleted, we talked about the retention period, right? Say for example, the retention period is 7 days. So after 7 days, all these events which were present, which got expired or older than 7 days, those will be removed from the Kafka, right? But when we talk about the consumer offsets, this is like the key value pair where each of the key will contain only the latest value, just like the case of hash map or dictionary, right? So say for example, the key is A, you store the value there 1. Next time again, if you do the put operation on A and put the value as 2, then it won't do A2 like this doesn't happen. What it actually does, it like update the current value. So there will be only one entry corresponding to A and it will contain the latest value. Similarly for this, whenever the committed offset is updated, it doesn't create a new entry there, it simply updates the value of that key. So there will be only one value present for the key. So using this way, it doesn't increase the volume of records because there is only one entry corresponding to each of the key, and it does not need to remove that key after that retention period of 7 days. Because in normal topics, we had huge data, right? All the events were present, and after 7 days or whatever retention period was there, we need to remove that. But in case of consumer offsets, this is compacted topic, which means it has very limited number of entries and it does not get deleted after the retention period because each of the key has only one value, which is the latest one. Now let me show you the complete flow of this consumer offset so that you get more clarity. Okay, we start with the step 1 where say for example the consumer, say it's a storage service which has the role to basically write the data into the database, right? So basically it subscribes to the message created event. So now it wants to pick the messages. So what Kafka will do is it will find the committed offset related to this storage service and this topic message created. So you know that we kept the key as the consumer group ID plus topic plus partition. So it will basically check this consumer group ID, the topic which is message created, and the partition number. How does it find the partition number? Basically it can use the techniques like hashing to identify the particular partition. So now it knows the key, it will search that key in the consumer offsets topic. So whatever value was present in the committed offset, now the consumer will start consuming from that offset plus 1 value, because offset is telling you the pointer from which you need to start consuming now. Till that part you have already covered because that is the committed offset, and the new value starts plus 1. So after that you have the new data which you haven't consumed yet, right? So you will start consuming for that particular consumer group from offset plus 1, right? So it's just like it gives you offset like this, which means this part of data has already been consumed by this consumer group. You need to consume this particular data. So it will start with offset +1. And as we discussed earlier, this offset will be different for each of the consumer group, right? So each of the consumer group can consume independently. So these were the two steps. So after these steps, let's move to step 3. Now say the consumer has consumed that message. Okay, like for example, we were talking about the storage service. So its role was to write that messages to the database, and say it has already done that. So after that, it's a responsibility of the consumer group to update that offset, because it's not the responsibility of Kafka to maintain like who has consumed it or not, because after the retention period it will simply remove that data. So it's the consumer group who needs to update it. So at the step 4, the consumer group will commit the new offset, because last time was the offset till the point it has already consumed. It got a new offset and now it has consumed some more data. So now it's a responsibility of the consumer group to update this offset. So what it will do is like consumer group will send the commit request to Kafka. So something like this will happen. So you can see this is offset commit request. It tells the group ID. So here it was like the storage service. It has the topic, which was message created. It has the partition through which you will make the key, because the key was combination of all three of these, right? And then it will also tell the value of new offset. Say earlier it was like 1500. Now it has consumed 50 more messages. So it will now update the offset to 1550. So this is the key and this is the updated value. So for this particular key, this value will be updated. It won't create a new entry on that particular key, only value will get updated, right? So next time, instead of this, it will get the value of offset as 1550 and it will start from 1551, right? Now how does that happen? That happens via this step 5, because like the consumer has committed this message. Now Kafka will write that to the consumer offsets. So based on this request, it will update the value of the key, right? And that's why next time you check for that same key, you'll get the updated value, which is 1550. So these are the 5 steps which are telling you the clear flow how things work using the consumer offsets. Now basically this all part related to consumer offsets and how things are stored. This is not related to this particular question, like where we were talking about like designing the group chats in WhatsApp or Slack. This was a generic flow which I told you about the Kafka, because when I was reading the flow related to Kafka, I had all such doubts. So that's why I thought I'll also clear all the doubts for you. But of course, when you are asked the question like design group chat in WhatsApp or Slack, you don't need to define all these concepts during your interview round, because you have limited time and you need to focus on the actual question. And I told you this so that you get clarity how things are actually stored in Kafka, and this will be really helpful for you because Kafka will be used in many system design questions. It's not just related to this group chat question. Kafka will be used in multiple places. So once you understand this flow, how basically the offsets work, what is the role of offset, and how does different consumer groups are you able to use the message independently, using this I got the clarity. So I thought I'll tell you, but I mean you don't need to tell this in the interview if the question is specific to, say for example, group chat. But yeah, of course, if the interviewer asks you, it's a great thing. It will show that you have the deep understanding and knowledge about the internal topic like Kafka as well, right? So let's go back to our original question. We were checking this diagram where we had all of these components. You can see here we talked about the client, we talked about the gateway, we talked about the message ingest service, and we now talked about the Kafka message queue as well. We discussed that like message ingest service will publish the event like message created into the Kafka message queue, and there will be multiple consumers of that, like the notification service, storage service, delivery service, search indexer, right? So we have covered like client part, we have discussed about the gateway, We also talked about the message ingest service, like it will publish the message like message created and publish that to the Kafka. And we discussed in detail about this, like the offset part in Kafka message queue, how things work for your understanding, right? And we also discussed like from the Kafka message queue there will be multiple consumers, like the delivery service will consume from it, the search indexer will consume for it, the storage service will consume from it, the notification service will consume from it, right? So now further let's talk about this storage service. What's the role of storage service in our system design of group chat of WhatsApp, and let's talk in detail about it. So the major role of storage service is to store the messages in the database so that the messages have persistent kind of storage, because the Kafka message queue has like storage retention period of like 7 days to 30 days, right? But we want like persistent storage for our messages, because you can see your messages even after 6 months, so you want persistent storage, and that's why we want to store the messages in the database. And you remember that we did not do that from the message ingest service. We can't just do like for each of the message you keep on hitting the database, and that too as your first step, because that will create a lot of dependency in your system and things won't work, things won't scale. So we did not store the messages directly from the message ingest service to the database. We published the events in the Kafka message queue, and various consumer groups are basically consuming that event from the Kafka, right? So one of the consumer group is the storage service, whose role is to store the data in the database. So the main responsibility of the storage service will be, first it will be consuming the events from the Kafka message queue, and then its role is to store those messages in the database for the persistent storage. It also ensures the idempotent writes so that there are no duplicate messages in the database, and that is done using the message ID. Now that we are talking about the database, it's also important that we discuss the entity. So like we are storing the messages here, so let me show you in detail about the entity that we will have. So like here you can see we have kept the entity named as messages. Okay, it will have the column, first is the ID, type of which will be the UUID, which is the unique message ID. Now the unique message ID will ensure that we are maintaining idempotency, which ensures that there are no duplicate messages. So just in case if you're writing something in DB and it fails, when you retry you keep the same ID for that retry, so that just in case the two of the messages go into the DB, we can clearly identify the ID is same, so that there is no duplicate. Next we have the group ID, because we are talking about the group chat, so group ID is important, which tells about which group we are talking about. Next we have the sender ID, because one person will send the message and we need to send that message to all others, so this tells who sent the message. Next we have the sequence number, which is basically telling the sequential numbering of the messages, because ordering of the message is really important when we talk about any chat, so it ensures that we are maintaining the order. Then there is the content, which is the actual message which is present, like the text message. Then there is column related to attachments. After that we have fields like created at, which is the timestamp, like what time this was created. Now that you know, WhatsApp also gives you an option to update the message, so we also have a field like updated at, which will show you at what time this message was edited. And then there is a status field which tells you status, like it is sent, delivered, deleted, etc. So generally when you talk about the database, you have to tell about the entity. So that's why this step of defining your core entity and what all major fields will be present in it is also really important. Okay, all right, this was about the entity and the fields which will be present. Now let's also talk about some of the indexing approach that we can use. So basically for ordered fetching, what we can do is like use the indexes on the group ID and the sequence number, because the sequence number is related to ordering, right? So based on the group and the sequence number, we can fetch the ordered messages. And for message history, we can index on the sender ID and the created time. And for pagination, we can index on the basis of group ID and created at descending order, right? So all such kind of indexing approach you can use. Let me basically zoom out all of these details, because we need to focus on the complete diagram. So let me also zoom out this entity part and put it near to the database. Now we talked about the sequence number related to ordering. If you want to know like how will we create a number like that, you can refer to my this video related to tiny URL, where we have discussed few of the approaches, like how can we define a counter which keeps on incrementing. So you can see all the approaches that we discussed in that. Now, as I told you earlier, one of the major roles of storage service is to maintain idempotency, which means we need to make sure there are no duplicates in the database. And how will we ensure that? Using the message ID, right? The message ID is the UUID, which will uniquely identify the message. So basically every time before the insert operation is done, we will check for the message ID. You can simply do that by applying the unique constraint on the message ID. So anytime you have two messages which have the same message ID, so say for example one of the messages is already present in the database with the message ID say 1, and now next time you are trying to write another message with message ID 1. So because we have put the unique constraint on the message ID, if it identifies like that message ID already exists in DB, it will skip that second message. And in case that message ID is not present, then of course the write operation will be performed. So in this way it makes sure that there is no duplicate. Now when we talk about the database, one question may come like how will you handle so many messages, because there will be huge number of write operations in terms of messages that will be happening. So how will you handle that? So we can say something like this. So basically we know that there will be millions of messages per second. To handle that, we will do the sharding based on the group ID. We will do the bulk inserts, which is the batch writes. It's not like for each of the message you are inserting it directly in the database, because in that way you will have millions of write operations in the database which cannot scale. So we will have the bulk inserts, like write operations in the batch. Okay, and then the third point, which we have already discussed but it is a very important part, it is that we are not inserting directly from our first microservice, which was the message ingest microservice, right? It's not like each of the message coming you are simply inserting in the DB. That was the first thing that I told you in the beginning of the video. If you are doing this approach, like every time a message is coming you are inserting in database, high probability you will be rejected from the interview, right? So what we are doing is like async writes from the Kafka. So we have the event stored in Kafka, and then there are consumers. One of the consumer is this storage service, and its role is to write the messages to the database. Now because it's an independent service, independent role, it can do it independently. It can write the messages in batches, and in case it fails as well, it doesn't stop the system, because Kafka will have that message for like 7 to 30 days, which is like sufficient period of time for you. You can retry your write operations and do various things in case of failover, because you have like sufficient time. It's not like as soon as message comes it's the responsibility that you have to put that in the database, otherwise the complete system will stop. It's not like that. You have the message in the Kafka, it will stay there for like 7 to 30 days. Now you have sufficient time, you can write the messages in the database in the batch, right? So you can reduce the load overall. So that's why it's a very important step that we use the Kafka, and we are writing in the database as bulk inserts, as batch writes, right? And apart from that, what we will additionally do is replica DBs for read. So it's like the master slave architecture, you can say, and one master and multiple slaves. So you will have multiple replica DBs for the read operation, right? We can also use like Cassandra for the fast writes, S3 storage for basically archived history. So all such things you can say. Basically how will you handle so much load, like millions of message requests per second? Now that we have discussed about the core entity here, like also we discussed like how we will handle the scale, we also need to discuss about the APIs, because we did not discuss about that part. So talking about the storage service, these will be the APIs which will be exposed. First API is related to the messages, which will be the post API, and the description is that it will persist the message. Now one question may come into your mind that we talked about the WebSocket protocol, right? And why are we talking about like post, get, put, delete here? So one thing that you need to know is that like when we have a protocol, like for example from the client, you are interacting with the server, say we are using the WebSocket protocol, it is not mandatory that after that, if we are talking about the internal APIs inside that multiple microservice or the complete system, it does not need to follow the same protocol which was coming from the client to server, right? And even when we talk about like client to server, we can use multiple protocols. It's like when we are talking about sending the message, we need the WebSocket because you need to be active for that part, but it doesn't mean that you always need to use the WebSocket protocol. For some other microservice, like for example the authentication flow or any other different flow, like if you have to see your user profile or anything like that, it's not that you will use WebSocket even for that. So which protocol to use depends on the scenario. Like we talked about the sending message part, because we want to give the real-time experience, in that we'll use the WebSocket. But it doesn't mean that even for authentication or checking the your user profile you will use the WebSocket. You can use multiple protocols. For one of the microservice or scenario you can use one protocol, and for some other scenario you may use a different protocol. Okay, so if you want to know in detail about that part, refer to this video. It contains like the basic fundamentals related to system design, which will give you a huge amount of clarity, so you can check that video. But yes, I mean the major summary is that you can use multiple protocols depending on your microservice and what scenario are you using. And internally also you can use different protocol. If the client is using WebSocket to server, then internal system can use a different protocol as well. Okay, so here is the first API messages, which is a post API which will persist the message. Next we have the API to fetch messages with the pagination. This is like groups, and then it tells the ID of the group and then messages. So this is a get API, right? Because there can be a lot of messages in a group. That's why we are using the pagination here. Next API to fetch the specific message. This also will be a get API. This is like messages and then ID. So because we are telling the message ID, it will fetch the specific message. Next, for edit message, we will use the put API similar to above one. We have similar kind of thing, but this one is put because we are editing the message. And similarly for deleting, we use the delete method. Same URL you can say, but this is for deleting. Now if you want to know more about different methods like post, put, get, delete, all such things, you can refer to this video of mine. We talked about in detail about it. So yeah, I mean all of these APIs will interact with DB, cache and the search index, right? So in this way you can tell about the APIs that will be used by the storage service as well. Alright, so let me zoom this out as well because we need to focus on the complete diagram, right? Now one thing is that I said the storage service will do the batch insert in the database. So naturally one question may come into your mind, what is this batch insert and how is it done? So the answer is, say your microservice keep on inserting each of the message in the database, right? You get a message, you insert in the DB, you get another message, you insert in the DB. So like WhatsApp, you have like millions of messages per second, so that way you will have like millions of write operations in the database. That is not a good solution. This will not scale and your complete system will go down. So we cannot insert each and every message one by one. So instead of that, what we will do is like batching. So this is the flow. Like consumer, which is the storage service, it will pull the messages from Kafka. Say for example, it will take like n messages. You can say like 100 or 500, so it can put that limit like n messages, or it can also put the threshold on the time. Say for example, after every t milliseconds, like 50 milliseconds. So whichever of these come first, like either you have like 500 messages or like you have reached like 50 milliseconds. So whichever of these two conditions related to quantity of messages or the time interval, whichever reaches first, you pick that, and based on that you perform the bulk insert into the database, right? It will be something like insert into the entity. We named the entity as messages. We saw all the columns which will be present in that table, right? So we are inserting into that table and we are mentioning the group ID, the message ID, the sender ID, context, created at, all that information we are putting. And then we are putting values, like because we have multiple messages here, we picked multiple messages, n messages from Kafka. So we will insert all of these in one go. So once this write operation is done using the storage service, what it needs to do is like it needs to commit the Kafka with the new offset, the updated offset value, because you have now already used that part. So earlier, say for example, you were till here, which meant like you have used all of these messages. Now you have to consume these messages. Now you took like n messages till here and you perform the write operation in the DB and say that was successful. So now this consumer like storage service needs to update the Kafka, right, with this updated offset so that it comes here, so that next time when you read, you start after this part. Like this is already done, you don't need to read it again. So that's why you need to commit the offset in Kafka, right? So in this way, basically you are not performing the write operation in DB for each and every message. So you are performing the batch insert. So in this way, your database will not go down. Of course, you will have some latency here because you are using the batch insert. You are not inserting every message in one go, but that's fine because that would be very low, because we are taking both of the factors, the quantity of messages and the threshold of the time as well. So we are anyways doing in the worst case like every 50 milliseconds, so that's not too much. So that is acceptable, right? Now because we are talking about the database, one more question that may come into your mind is like, how does it handle attachments like images or videos? So basically the flow related to the images and videos is bit different as compared to the text, because generally we don't store the assets like images, videos in the database directly. If you want to know more about that, you can refer to this video of mine where we have discussed completely in detail like how do we handle the scenario of images and videos. But if you want a small summary, what we do is like we use S3 storage. So instead of the database, we store the images and the videos in the S3 storage. Now there are many things involved in it, like who will upload it, will it the server, will it the client? I would refer you to watch this video. You'll get more clarity, complete in detail. You'll get like how things work for images and videos. And why I say that you need to see this video, because it's not just related to a WhatsApp or group chat. It's a very generic concept. So when we talk about images, video, for whatever platform, it can be Netflix, it can be YouTube, any other thing. So we generally use similar kind of thing. So you need to understand that concept. It will be really helpful. So go watch this video and you will get clarity how do we basically handle the attachments like images and video. But if you want to give me like brief summary, there is this client, let me just write C here, and then there is the microservice, right? So let me write S here. Okay, so one possibility is that client uploads the attachment like images, videos to server, and then server can do it to the S3. The problem in this process is that you are basically uploading or downloading your assets twice, first from client to server and then server to S3, right? We don't want to do that because it's like duplicate effort. You are doing multiple times, and also in that you need to make sure that the server has that much capacity, because you are storing like videos in it and videos can be in GBs. So the server needs to have that much high kind of storage. It needs to scale according to that. We don't want to do that. So what we will do is like from the client directly we will upload or download the images or videos to the S3 storage. Now of course I understand that we don't trust client that much. So what we will do is like from the client we will send the request to the server. It will contain the images, videos, whatever the attachment is there, and it will also contain the metadata related to that image or video, because there can be other information as well, like the created time, what format is it, what's the name, all that information, right? So the client will send that to server. Now server will generate a pre-signed URL. Let me write it down for you. Pre-signed URL. So basically the server will interact with the S3 and it will generate this pre-signed URL, and the server will basically store the metadata, like I told you, the file name, the created time, the type, all that information, sender, like uploader, like the client info, all that things in the database, because that can be stored in database, but the proper image or video, that won't be stored in database. So once it has that pre-signed URL, so basically server will put that information of metadata in the database and set the status as uploading or in progress. Now it has the pre-signed URL, it will return the pre-signed URL to the client. Now what this pre-signed URL is, that the client will get permission to write at a specific location in S3 for some time. Okay, for some specific time the client can directly write to the S3 in a particular location. So once that operation is complete, the server will get to know, and it will update the database where it had put like in progress or uploading to done or uploaded, right? And it will also have the URL where it is stored in the S3. So in that way you are directly uploading to S3. That is happening only once. We are not uploading to server, and the information is completely present in the database, and we are not giving complete control to the client, because we are providing the pre-signed URL from the server to client, and that would be valid for limited time period. So this is how basically things work for the attachments like images or videos. Of course I did not go in complete detail. If you want to know, again refer to this video, you'll get great clarity. Okay, watch this video. So basically we just talked about the storage service. First thing is like storage service will be a consumer group of the Kafka message queue with the topic message created, right? It is listening to that message, and based on that it will perform some tasks. So its role is to insert the data in the database, right? So basically we have used the arrow to define like what is the role of the storage service. It is listening to Kafka message queue, and the major role is that it will do the batch insert in the database. Okay, just like the message ingest service publishes the event which was message created in the Kafka message queue, the storage service will also publish an event in the Kafka message queue which will be message persisted. So let me write it here. For this one we had like message created event, and for the storage service we will have like message persisted, right? So when will this storage service publish this event message persisted to the message queue? It will happen once it has stored the data in the database. So once the data is stored in the database, it will publish an event called as message persisted in the Kafka message queue. Now like we saw the message created event, there were multiple consumers. Similarly for message persisted event also there can be multiple consumers, because it signifies now we have that message in the database as well. So the data is persisted now. So that can be used in the analytics or many other fields, right? So the major part is there will be multiple events, multiple different topics in the Kafka message queue, and different microservices can publish various topics in this Kafka message queue, and there will be multiple consumers for each of the topic. So we discussed about the storage service. Now let's next talk about the delivery service. So first of all, there might be confusion that we have the delivery service as well as we have the notification service. Why have both of these? So basically delivery service will act as like fan out, because you have multiple people in the group, right? There will be multiple people, like 50 people in the group. Now when one user sends a message in the group, so we need to send that message to all the people in the group, right? That is done by the delivery service. And how does it sends that message? Using the WebSocket protocol. As we discussed about the WebSocket protocol in the beginning, we want real life experience for the chat application, right? So that's why we are using the WebSocket, and the delivery service will use the WebSocket protocol to send the message to all of the users which are present in that group. Whereas the notification service is to send the notifications or in-app notifications. Generally you might have seen in case of WhatsApp, if you are not currently using WhatsApp, if your that screen is particularly not open, then you get the notification. So you can imagine multiple cases like your WhatsApp application is currently closed, so there is no active WebSocket connection. So at that time notification service has a big role to play because it notifies the user that there is a new message. So basically delivery service acts as like fan out, where it will try to send the actual payload or message to the user, whereas the major role of notification service is to send alerts to the user. So just like the storage service was listening to this message created event or topic which was present in Kafka, similarly the delivery service is also listening to this event or topic which is message created. So whenever it gets like message created, it will basically check for each of the user who is present in that group. So for every user, if the user is online, then the delivery service will simply deliver the message using that WebSocket protocol that we discussed, right? But just in case if the user is offline, then what it can do is to push that message into the offline queue. That offline queue can be based out of like using Redis or some Kafka message queue topic, but the main funda of keeping that message to try for the delivery later. So let me put an arrow because the delivery service is listening to this message created event from the Kafka, right? In that case, what it will do is like it will publish a new event or topic into the Kafka message queue, and name of the topic will be message delivered because it has delivered the message to the end user. Now similar to other topics that we created like message created or message persisted, multiple consumer groups can consume this topic as well, which was message delivered. One of the use case of this can be like the client can be displayed that the message has been delivered to the other user. So you might have seen in WhatsApp we show the double tick that can be done based on this message delivered topic. Now there can be one question in your mind. We said for the delivery service it will check for each of the user whether the user is online or offline, and if the user is online we will deliver the message directly using the WebSocket. In case the user is offline, we will put that message in the offline queue, which can be using Redis or the Kafka message queue, different topic, right? But how do you identify whether the user is currently online or offline? The answer of this question is using the presence service. Basically the presence service will tell you whether the user is currently online or offline. We will talk about the presence service, but for now let's assume you will get whether the user is online or offline using the presence service. Now that you know whether the user is online or offline, you can apply that funda. If user is online, use the WebSocket. If user is offline, use the offline queue. Now there might be a question in mind like how does this offline queue things work? So let's discuss about it. So basically the delivery service will find out whether the user is online or offline using the presence service. Now let's assume that the user is currently offline because we want to discuss about the offline queue flow, right? So in that case what will happen is the delivery service will store the message which will contain like group ID, message ID, sender ID, timestamp, all that information it can store whether in Redis or as we are currently already using Kafka, so it can store in a new Kafka topic which can be offline queue, and after that we need to put the user ID because this delivery is specific to the user, right? So you have that information now, let's say in the Kafka topic. Apart from that there was another consumer group, right, which was notification service. So the notification service will try to alert the user. We'll discuss about the notification service later in this video. So this was a case when the user was offline, which we got to know from the presence service. Now say after some time this user becomes online. So now what will happen is the presence service will mark the user as online. How does that happen? So basically when the user opens the application, there will be an active WebSocket connection which will be formed, and that's how like presence service will mark the user as online. So the delivery service will get to know because it is listening to the events which are published by the presence service. So then what the delivery service will do, it will replay the undelivered message from the Kafka topic of that user. You can see here we created the topic offline queue with the user ID. So it will pick the undelivered message from here, and then now the delivery service will push those messages via the WebSocket. Why WebSocket? Because now the user is online, and once the message is delivered to the user, it will simply remove those entries from the offline queue because those are now delivered. We kept them in the offline queue because they were at that time undelivered. Now that we have delivered those, we can remove those from the offline queue. Now which one to use here, Redis or Kafka? Redis is more quicker, it's more faster, and also you can do easy eviction like using the TTL, whereas Kafka is used when you want at least once delivery, because you know there is a retention period in Kafka, so it stays there for longer time and you can retry in case of failures. So Kafka gives you delivery guarantee, right? Whereas Redis is quicker and easy to do the eviction. So it depends on the scenario. Just in case we want like at least once delivery, using a Kafka topic is better in this approach. So coming back to this diagram, how the flow looks like when you get this message created event from the message ingest service, it is published to the Kafka message queue. Delivery service is basically listening to this topic. Now because the delivery service has to deliver this message to all the members of that group, it needs to first know who all are the part of that group. So either it will check from the cache or it will check from the database. Now once it has the list of members which are part of that group, for each of the member it will check whether the user is currently offline or online. How does it get to know? Using the presence service. Now this information whether the user is online or offline can be present in the cache, or you can say the connection manager or the registry, and through that it can directly identify. It's like the key value pairs and you get to know whether the user is online or offline. Just in case, now if we know that the user is currently online, so we can send the message directly to the user using the WebSocket. So that may appear something like this. You can see we are doing the WebSocket push. We have the connection ID. Connection ID here represent like the socket where the user is currently connected to. Like we have this connection manager or the registry which tells like in which machine which socket ID the user is currently connected to. So we have that information now and we will basically send the message in the payload. So in this video we are not talking about the case where the user is connected to multiple device. So just in case we have the scenario that we have to send the message where user is connected to multiple devices, like user is using WhatsApp on the mobile phone as well as user has logged in on the web browser for WhatsApp. So in that case what we will do is like similar to this, we will send the message using the WebSocket to all of those connections. So you can see one connection ID here. Similar to that we will have multiple connection IDs if the user is connected to multiple devices. So for each of the connection ID we will send the message like this. Now this was a case if the user was online. Just in case if the user is offline, we will push the message in the offline queue, which we can do using a different topic in the Kafka message queue. And once the user is online again, we can pick those messages from the offline queue which were present in the Kafka topic, and then we can send the message to the user using the same approach of WebSocket as the user is now online. Now once the delivery service has delivered the message to the user, it can publish a topic which is message delivered in the Kafka message queue, which can be consumed by other consumers. One of the use case that we talked about was like the client can show the double tick on the message to the user because now the message has been delivered to other user. Now let's talk about one of the questions. We know that in WhatsApp we generally have a limit like 100 people in a group, but how will you handle it if there are like 1,000 people in the group? So it's a huge group. How will you handle that scenario? So basically if we talk about the large groups where the members are like more than 1,000, although this is a very limited case because generally when we talk about in WhatsApp you have like the limit, it can be like 100 people maximum in a group. But if you have to take the scenario of like more than 1,000 members, then what we need to do is that for the delivery service, the delivery will happen in parallel using the thread pools and also batching. There will be push worker pools, so there will be multiple workers which will perform this task. You can't put all the load on one thing, so there will be multiple delivery workers and we will distribute the work and those can work independently in parallel. So similar to that we will have like partial fan out queues. So here you can see an example. The delivery service will publish something like the fan out work which contains the group ID and the batch user IDs. So multiple workers process the batches. So basic funda is there will be multiple workers which will perform the task. Now let's discuss about an important scenario about the failure case. What if you tried to deliver the message but it failed? So basically what the delivery service will do, it will retry. Say for example we keep a threshold like X times. Just in case it is not able to deliver the message using the WebSocket, it will mark the user temporarily as offline and it will add that message in the offline queue so that it can retry later once the present service tells again that the user is now online. Now just in case the delivery service crashes, there are no worries because we already talked about like Kafka message queue will provide you the durability, the reliability, because it has like the retention period of like 7 to 30 days, which is configurable. But even if say we have kept it like 7 days, we have enough time to recover from the failure case. So just in case the delivery service fails, it won't commit the new or the updated offset in the Kafka message queue. So the Kafka message queue for the delivery service will have the old offset again. So in case the delivery service fails, once it is back, it can pick the offset from the Kafka message queue, which would be the old one, and again it can retry for delivering those messages. And here we were delivering through the WebSocket, and say like the WebSocket connection, there was a failure in that part, it failed. So we have the connection manager or the registry out there, which will clean the stale connections. And once the connection is built again, the delivery service can deliver the messages using the WebSocket. So this was about the delivery service, but the major point to remember is that delivery service is listening to the message created event. It does not perform delivery based on other events. It is based on the message created event, so that overall the complete flow is quite quick. Because if it waits for like message persisted event, then there will be huge delay. It would be acting like first the message will be saved in the database, after that you can do the delivery. No, that's not required. All of these consumers can perform their task independently. That's why we have different offsets per consumer group in the Kafka message queue, right? So all of these can perform their task independently. Like you can see, storage service is storing the messages in the database, meanwhile the delivery service is delivering the messages to all the people who are present in the group. And similarly other consumer groups can perform their task, right? So one more thing, when we talk about like the message application, there is end-to-end encryption, so E2EE. Okay, I have not talked about the end-to-end encryption in this flow, but if you want to know about end-to-end encryption, how things work in that, you can refer to this video. I have discussed in detail about the end-to-end encryption flow in WhatsApp in this video. So go check that out, because you'll get a good and new information. For the first time when I learned about that end-to-end flow, it was quite interesting and I had a lot of fun understanding that flow. So refer to that video in case of end-to-end encryption. We are not going to talk about encryption in this video due to time constraints. So this was about the delivery service. Next, let's talk about the present service. So the present service has multiple roles, like whether the user is currently online or offline. It is also used to show the last seen of the user, and similarly it is also used to show the typing indicator. Say a user is typing something, you get to know user A is typing. How do you get to know? Using the present service. So let's try to understand how things work. So basically whenever the user opens the application like WhatsApp or Slack, in that case WebSocket connection is built. Of course there is authentication flow. First time if you are doing, you have to do login using your mobile number, OTP or email, whatever authentication flow is there. If user is already logged in, then the authentication happens using the JWT token using the gateway. So once the WebSocket connection is built, the present service will get an event user connected. Now based on that information, present service will update the information of that user, that the current status of user is that the user is online, and it will also update the updated time, like this is the timestamp at which we updated the status. Now once the present service has updated this, it can publish an event to a topic in Kafka message queue, which can be something like user online, and many consumers can consume that. For example, we just saw delivery service wants to know whether a user is online or offline. So how will it get to know? Basically it can keep on listening to that event, the user online event, which the present service will publish, and based on that delivery service can basically check if the user is now online and perform its pending task. Like for example, something was present in the offline queue, it can retry for that user. Now for the present service, we mentioned that it will update the data of that user, that the status of user is now online, also the last updated time and all that information, last seen, everything. But the question comes is, where does the present service will store all that information? Will it use the database? The answer is no. Why? The reason is, you see all that information, whether the user is currently online or offline, or what was the last seen. This is kind of data which will keep on changing very frequently, right? And you generally show only the last seen, or whether the user is currently online or offline. You don't need the old data, right? Whether like 5 days ago user was online or not, and what was the time. You don't need all that, you just need the most frequent one. So what the present service can use is like the key value pair system. So we can use Redis cache for this operation. Instead of using the database, we can simply use the Redis cache, and using that the latency also is quite low, because Redis cache is quite quick. So we'll get quick information whether the user is online, offline, or what was the last seen. All that kind of information we can get directly from the Redis. So the present service will use the Redis to store that information. Now that can be something like this. You can see it says presence, user, and user ID, right? This is the key, and based on that we have maintained the status, like status is online, last seen is currently null because the user is currently online, right? And we have mentioned like updated at this time. So this is the key and this is the value. So in this way it can maintain all that information in the Redis. And say now the user has closed the application, then the WebSocket connection which was active, it will be closed, and based on that the present service will get the event, and it will again update this information for this particular key. It will make the status to offline, and it will update the last seen because it had the updated time, and it will also modify the updated time to the new time. So in this way the present service will update it, and then it can also publish an event to the topic of user offline. So in case if you want like last seen as like persistent storage, like you want to keep that, you can keep that information of last seen in the database. So you can have like Cassandra database where you can maintain last seen. But in generic, like the present service is meant to be a very lightweight kind of service, because these are kind of additional features that you are providing, right? If user can see whether other user is online or what's the last seen, all that information. The major functionality is that you are able to send the message in the group. So that's a major thing. So even if you keep all this information just in the Redis, it's fine, because it's not a very big deal to show the last seen. Similarly, if we talk about the case of typing, say user starts typing, so the client will send information to the gateway that user is typing. So the present service will get to know. Based on that, it can publish that event to a topic in Kafka message queue, so that if any of the particular consumer group wants to consume it, they can use it. Similarly, it can have that information in the Redis, because typing related information is also something which gets modified quite quickly. Like currently user is typing, after 10 seconds the user might not be typing. So you don't need to keep all that information in the database, you just can maintain that for some time in the Redis. But the main funda of this present service is that using this you'll get more information whether the user is currently online or offline, and many other things. Like it will tell about like whether user is currently typing or what was the last seen of the user, right? So the present service will also publish some of the events to the Kafka message queue which can be used. Like it can say like user online, user offline, and many other topics which multiple consumers can consume. Now we understood, like for present service, if the user opens the application, then of course a WebSocket connection will be built and you will say the user is online. If user closes the application, the WebSocket connection is closed, and hence you'll get that user is offline. But what about like user is currently using the application? How will the present service will modify things? So basically it uses like WebSocket heartbeats. So after every certain threshold there will be heartbeat check, through which you'll get to know whether the current user is online or offline. If you don't receive the heartbeats after some time for particular threshold, you can mark that user as currently offline, because there can be scenarios like there is no internet connection now available for the user, somehow the Wi-Fi got disconnected, and any other scenario can happen like the phone restarted. So in that case there won't be any heartbeat received from the WebSocket to the present service, and say it's not receiving the heartbeat and it has crossed a particular threshold like 3 times, continuous, it hasn't received the heartbeat, so it can basically mark that user temporarily as offline, right? But because we are using the heartbeat, so of course there will be like some delay. So just in case, like if the user was online 5 seconds ago, and if someone is checking for that particular user, then you can show the status as online only, because that's something like eventual consistency, which is totally fine. If the user was like online 15 seconds ago and you are showing that online right now, it's totally fine. It's not that big deal. And also, as I told you earlier, this is a very lightweight service, and the features that we are talking about are really kind of add-on features which are not the mandatory kind of thing. That's not the core USP of WhatsApp or Slack. The core part is that you are able to send the message in a group and all the people are able to receive that. So all that kind of major functionalities are the core requirements for this. Like the eventual consistency is totally fine. So because we are using the heartbeat system, there would be some delay. And like if user was like 10-15 seconds ago online and you don't have the current stat, you can say that as currently online. That's totally fine. So this was about the present service. Now we have covered message ingest service, Kafka, storage service, delivery service, and the present service. Next, let's talk about the notification service. So the role of notification service is to notify the user, to give the alerts, like the notifications you might have seen. You get a sound and that one notification that appears to you whenever you get the message. It can appear to your normal screen or even on the lock screen, depending on the whatever setting you have set in your phone. And apart from the normal notification, we can also have something like an in-app notification, which can also be done using the notification service. So you might have seen, like if you are not currently using the application like WhatsApp or Slack, if there is some message, you get the notification, and through the notification, through that sound, the vibration, or that message, you get to know there is a new message. And you check that. So the notification service is really important when we talk about like a chat application. So the notification service is also listening to this message created topic, right? So this is also one of the consumers of this topic. So this is not waiting for something else to happen, like the message persisted or message delivered. It is not waiting for all that. As soon as you get this message created event, all of these consumers can perform their task independently. So the notification service will also perform its task to send the notification to the user. So as the notification service is also one of the consumer group of this message created topic, so let me create this arrow because it is listening to this topic. And once it gets like message created, similar to like delivery service, its role is to get all the users who are part of that group, and then it will try to notify or send notification to those users. How will it do that? So basically, if we are talking about the Android mobile devices, we use FCM for that, which is basically the Firebase cloud messaging that is used for Android. And if we talk about iOS, we use APN, which is basically Apple push notifications. So using this, we will be able to send the notifications to Android and iOS devices. So basically, when I was trying to understand this complete system design flow, one question that came into my mind was like, say all of these, like the delivery service, the storage service, notification service, they are listening to this message created, and they are performing their task independently, right? There can be a case like this notification service sent a message to the user. Say for example, that message was till now not stored in the database, and maybe it was not actually delivered using the WebSocket. If the notification does not contain the actual content, it is just redirecting you to the application. It might happen that you don't see that information when you go to the chat, but you got the notification. And I think I have seen that kind of case in my Slack application or WhatsApp also. You sometimes get the notification first, but when you click on it, you go to the chat, but you're not able to see that new chat for now, and it gets updated after some time. So that may happen because all of these are using like the same event message created, and they are performing their task independently. So that kind of scenario can happen, and I mean it totally depends on your product requirement. Just in case if you want that the notification should go only after, say, the message is persisted in database or once it has been delivered to the user using WebSocket, then what we can do is, like, instead of listening to this message created event, the notification service can also listen to, say, message persisted event, because message persisted happens when you have stored the data in the database, or you can do that on message delivered event, which means that you have delivered that message to that user and then you are sending the notification. So it's basically totally about up to you, like how you want your product to work, right? But of course there are pros and cons everywhere. So when we are talking about, like, we are sending the notification on message created, yeah, we saw that case, like it can happen, the data is not actually present on your application but you saw the notification. But the good side was it was quite fast, you got the alert instantly, whereas if you delay this part on message persisted or message delivered, of course you won't get that kind of scenario that you are not able to see the latest thing on the message application because you are sending the notification only after doing that, but it will be delayed kind of thing, right? You'll get the alert after some time. So I mean totally depends, but you can see we have made such system that you have the flexibility, you can use whatever, because we are using the Kafka message queue, and it's simply like your notification service, instead of listening to this topic, it will start listening to this topic or this topic. So in technical terms you can do that. So we are designing such kind of system that can handle it, right? So but if we talk about this kind of scenario, I think this is totally fine. You can keep on listening to message created event, and at least you are getting the notification or alert, and you know that some message has been received, and when you open the application you don't see that, you know it might be some issue on internet or it may take some time, but you know there was a message and you try to refresh and you get the latest one. So in that way I think it's a good case, good scenario, and people want to have that. So we will keep on listening to message created event for all of these, and I think that is a good design. Yeah, but here you can clearly see we are using both the delivery service as well as the notification service. The role of delivery service is to deliver the actual message to the device using the WebSocket connections, whereas the notification service, the main role is to notify the user. So just in case you are not active on your device, you're not looking into your application, which can happen, right? So the notification service will notify the user using that notification or some badge or the sound from that. Even if your device is like kept bit away from you, you hear that notification sound and you get to know, okay, there is some message, right? So we are using both of these in our system. All right, so this was about the notification service. Now next let's talk about the search indexer. Now the first question may come, like, why do we need a search indexer? So basically in a chat application you might have seen many times that you try to search things like finding messages which contains meeting in the general group, or in the group you are searching like happy birthday because you want to remember, like, last time when did I wish this person happy birthday. So corresponding to that you will remember, okay, this is the date on which he or she has the birthday, right? So you search a lot of things in the chat, right? But just imagine whenever you are searching, if we are doing a query on your database, like the query be something like select star from messages was our core entity, the database entity, right? So we are doing select star from messages where text like meeting, because we are trying to search keyword meeting, right? So if we do query like this will be very slow. So that's why we need a search indexer, where we generally use the concepts like Elasticsearch, so that your search part is quite fast. So here the search indexer service, this is also one of the consumers of this message created topic, right? So let me also put an arrow here. Okay, too many errors, confusion here, so let me do something like this. Okay, so basically the search indexer microservice, it is also listening to this message created topic. So basically this microservice listening to this topic, whenever it gets the message, it will create a document which will contain the information like the message ID, group name, who sent, what was the text or the message, what was the timestamp, all that metadata information it will maintain in a document, and it will do that for each of the message. So all of these consumer groups are independent to each other. So basically once it has created the document with the actual content as well as all the metadata related to it, it will then use the Elasticsearch, or it will call the Elasticsearch, so that that document which it had created, which had all the information as well as the content, it becomes searchable now based on any of the field which the document had. So now when the user tries to search something in the chat, it will go to the search indexer service, which will call the Elasticsearch, and the Elasticsearch will return the matching messages. Similarly, if a message is edited or deleted, even in that case the search indexer microservice will call the Elasticsearch to reindex in case of edit and removal in case of delete. Now if we talk about the failure scenarios here, because we are using the Elasticsearch, right? In case the Elasticsearch is down, it's not working, then what the search indexer service can do is like it can put that data in the DL queue, which is dead letter queue, which means once the Elasticsearch is up again, there can be retry workers which will pick the data from the DL queue, which is the dead letter queue, and they then try to do the task in the Elasticsearch. And just in case the search indexer microservice is down, then we have already discussed that Kafka provides us durability and reliability. It has the retention time period. So in case this microservice fails or goes down, it won't update the new committed offset to Kafka, and that's why next time when it is up, it will pick again from the old offset, and so none of the data is missed. Now let's discuss one of the scenarios. Say there are like 100,000 members in the group. So how will our complete system handle that kind of load? So first, if we talk about the gateway component, we will do the horizontal scaling, which means there will be thousands of instances of the gateway because we need to handle so much load. So which API gateway or load balancer is picked, that will be done using the consistent hashing, right? So the API gateway or load balancer, they don't need to know the logic of the microservices, so it is acting as a separate component. So basically, as we have done the horizontal scaling, so there are many instances of the gateway, and using the consistent hashing, we are reaching out to particular gateway and load balancer. So in this way, this component is sorted. If there is more load, you can scale it more horizontally. Now next, if we talk about the message ingest service, of course we can scale it horizontally, and in our design the major part was that it is not inserting directly to the database. Its major role is to simply push the message in the Kafka message queue. Hence the message ingest microservice is not impacted by, say, there are 100k members in the group, because it has to simply publish any event to the Kafka message queue. In that way, we don't need to modify or make any changes in this microservice. Next, if we talk about the storage microservice, then because its role is related to database, we need to think of one scenario. For one write, there will be huge amount of read operations. Now one good thing is that we are writing the message only once, irrespective of the group size. So even if there are 100k users or like 2 users, we are writing the message only once, so that way it is good. Now what we can do is like do the optimizations in the database. We can do it for like append only writes, and we can use the database like Cassandra DB or the DynamoDB. Then we can use like the master slave architect. We can have multiple read replicas for the database. Then we can also apply techniques like indexing here. Then one thing that we may try is like something like a pre-computation, and for database we can think of sharding and other techniques. Now next, if we talk about the delivery service, this is the one which is highly impacted by the number of people who are present in the group, because the delivery service is acting as a fan out. So in case there are only 3 people in the group, it has to deliver message to only 3 people, whereas if there are like 100k members in the group, the delivery service has to deliver the message to 100k people. Now here we can use multiple strategies. First, we can't put all the load on one thing, so we will have multiple delivery workers, and each of the delivery worker will have particular threshold, like it will see some threshold messages only, and we can do grouping in that way. Next part is if you have 100k people in the group, you don't need to send real-time messages to all of those. We can think of sending to only those who are currently online, and even in that some of the people don't actually use the group very frequently, or some have muted or archived the group, so we can ignore some of the people out of the group. So we can focus on only the active people in the group for real-time delivery. So it means like cold users who are inactive, we don't need to give the real-time kind of experience to those, because they don't even check the messages. This group might not be important for them. Now for fan out, we may use hierarchy in the fan out architecture. So first we see at the global level, then at the regional level. So we will have the delivery workers or the fan out workers at the regional level, you can say. Now next, if we talk about the notification service, similar to delivery service, we can do similar, like if the users are inactive, we don't need to send the notifications instantly to them. We can focus on the active users for now. And then we can also perform the task in batching. There can be multiple workers and they can distribute the task into subtasks. Next, if we talk about the present service, as I told you earlier, this should be the lightweight service. It provides like additional features, like you can say who is online or offline, what's the last seen, and similarly it will show you that some user is typing a message, right? So one thing that we can do here is, like, because there are so many members in the group, we can show the aggregated results here. Like for example, 5.2k users are currently online and something like multiple people are typing. We don't need to fan out here for each of the user. We can basically send the summary updates after few seconds. So there is one more consideration. In case there is huge load on the system, we don't want this microservice to put additional load on the system. So in that kind of scenario, you can also show the estimated kind of results for this, because this is not the most important feature of the system. So we can rely on aggregation here, sampling, estimation, and showing some standard text like multiple people are typing. So all that things we can use in the present service. Next, if we talk about the search indexer, we can scale it horizontally, but the main part is that we can do the bulk ingestion via batch workers, and there is not much dependency on this particular microservice. If there is even lag in this, it's fine and it's acceptable. So the major thing is on the delivery service, it has to avoid explosive fan out to all the users in one go. It can focus on only the active users. There can be multiple delivery workers which can do regional fan out. Alright, this is how your system can also handle the scale where the group size is too big. Alright, so overall this is the diagram. You can see all the components here. If I talk about each of the component in very brief, so first we have the client. It can be the user using the application on mobile phone like Android or iOS, or the user using your web app or website on the browser. Okay, then we have the gateway and the load balancer. The API gateway will perform three major tasks. One is like authentication using JWT token. Second is the rate limiting. And third is to forward the request to the correct microservice. Then you have the load balancer, which is used to balance the load in case of horizontal scaling, because in a microservice you will have multiple servers. So to which particular server the request should go to, it will be decided by the load balancer using the consistent hashing. Then we have the message ingest microservice. Its major role is to publish the event in the Kafka message queue. Here we have named that topic as the message created. Now Kafka is a very important part of this system design, because through this you can see all the communication is happening. An event will be published to a topic in Kafka which will be consumed by multiple consumer groups, right? For example, the message created event was published by the message ingest microservice, and then there are multiple consumer groups which are listening to this topic, right? So let's start with first with the storage microservice. It will listen to this message, and its main role is to persist this message in the database. And once it is able to do that, it will publish an event to the topic which is message persisted. Then we have the delivery service, which will also listen to this message created topic, and its role is to do the fan out. So what it will do is that it will deliver the message to all the members who are part of that group. It will first check if the user is online or offline. If the user is online, it will use the WebSocket protocol to send the message, and in case the user is offline, it will put that message in the offline queue, so that once the user gets online again, which we will get to know using the present service, we will again retry to deliver the message to that user as the user is online now. So we will use WebSocket for that, and once it delivers the message, it will publish an event to the topic message delivered to the Kafka message queue. Next, talking about the present service, its role is to tell whether a user is online or offline, what was the last seen of the user, if someone is typing a message. So all these features are provided by the present microservice. It will also publish some of the events like user online, user offline to the Kafka, which will help other consumers to perform their task. Like we discussed, the delivery service will check if the user is online, it will use WebSocket, otherwise it will use the offline queue. Next, we have the notification service. It will be used to notify the users. For Android, we use Firebase Cloud Messaging, and for iOS we use Apple Push Notifications. Next, we have the Search Indexer microservice. It will basically use the Elasticsearch so that we are able to get our search results quickly. And here it was the connection manager or registry, which is acting as, you can say, in-memory cache, which will tell you like which user is connected to which machine and the socket. So using that, you will be able to send the message to a particular user, right? So this was the overall diagram. We also talked about the entities and the APIs earlier. There are few important parts to keep in mind. First, the most important, we are not directly inserting the messages in the database, right? We are not doing one by one each and every message you are performing the right operation, because that is the wrong strategy. We are using Kafka as a message queue because Kafka has the retention period of like 7 to 30 days, and it is capable of a scenario where there are so many write operations. Next part to remember is that all of these consumer groups like delivery service, storage service, notification service, search indexer, they are performing their task independently. So it is not happening sequentially here. All of these are performing tasks in parallel, independent of each other. All right, so this was our system design for the group chat in the chat application like WhatsApp, Telegram, Facebook Messenger, Slack, or Teams. In case you found this video helpful, press the like button, subscribe to the channel, and share it with your friends so that all of us can learn and grow together. In case you have any doubts, put that in comment section and I'll try to help you out. Alright then, this is Mohit Chabra signing off. Subscribe to the channel and thanks for watching.